The last thing we'll look at today is the projection of u onto v. Visually, what the projection is let's say that you have a vector u, and let's say that you have a vector v. The projection is almost like a shadow. If you were to draw a perpendicular line down from u onto v, the projection is this shadowed area right here. As if you're shining a light onto v from u. Okay? This is probably the most complicated formula of the day, but I believe all of you guys can do it. The projection of u onto v is the dot product of u in v divided by the magnitude of v squared multiplied by vector v. Okay? In example 5, we'll get to try this out. Find the vector projection of u onto v, and we're given both vectors. Then write u as the sum of two orthogonal vectors, one of which is the projection of v. So let's do one thing at a time. We'll find the vector projection. So I'm going to follow the formula. The projection of u onto v equals the dot product. So to define the dot product, we'll multiply the x's together. 6 times 5 is 30. Plus, I'm going to multiply the y's together. So 2 times negative 5 is negative 10. Divided by the magnitude of v squared. So to find the magnitude of v, you do the square root of x squared plus y squared. So x squared, 5 squared is 25, plus y squared, negative 5 squared is also 25. Then, just like the formula over here, we're going to square it. Once we get this answer, it'll just be a scalar number. We're going to multiply that times the vector v, so then it goes in the same direction of v, it's just a different length. So the vector v is 5, negative 5. Okay. From here, I'm going to simplify a little bit. 30 plus negative 10 is 20. 25 plus 25 is 50, and the squaring and the square rooting are inverse operations. They're going to undo each other. So 25 plus 25 is 50. I can probably simplify this a little bit more, because 20 over 50 can be reduced to 2/5. Okay. Last but not least, I'll distribute. So 2/5 times 5 is 2, and 2/5 times negative 5 is negative 2. That is our vector projection. The second part of the problem says to write u. So u is 6, 2. As the sum usually means to add. So I want the sum of two vectors. So I'm going to have one vector plus another vector. That's the sum. It says one of them is the projection. So I already know my projection. My projection is 2, negative 2. I would like to find the other vector. So just like algebra, to undo addition, we're going to subtract. We're going to subtract the projection from both sides. So that unknown vector that I would like is just going to come from the subtraction. So 6 minus 2 would be 4. Those are the x's. From the y's, 2 minus negative 2. Well, minus a negative is the same thing as adding. So 2 plus 2 is 4. That equals our unknown vectors that we didn't know before. So the answer to the question is actually an equation where we're going to write u, so that is 6, 2, as the sum of two vectors. So one of our vectors was the projection, and then the other vector was this one that we just found. So this whole equation is the answer to the second question.